Hi, in this video we're going to talk about the last unit of AP Chemistry, which is electrochemistry. And now, to talk about electrochemistry, the first thing I'm going to need to learn is the types of cells. And there are two types of cells. The first is Voltaic Cell. V-O-L-T-A-I-C, Voltaic Cell. And these cells are spontaneous. Now, in these cells, you have what's called anode and cathodes. And now, anodes are the ones that are getting oxidized. And cathodes are getting reduced. So this is a redox reaction, and whichever element is getting reduced is the will be the cathode, and whatever is being oxidized will be in the anode. And the way to remember that is that the red cat gets fat. So reduction happens in the cathode, which gains electrons, gets fat. So reduction means gaining electrons. And again, the way to remember that is oil rig, which is oxidation is losing electrons, reduction is gaining electrons. Alright, now that's all for anode and cathodes. Next, we talk about reduction potentials. And the reduction potential is the tendency of a substance to gain electrons. So how it will be representing a number. And normally this reduction potential will be given to you. And when you have the reduction potential of two elements, the more negative the reduction potential equals, the less likely it is to be reduced. So the higher the reduction potential equals, the more likely it is to be, when you're comparing two substances, the higher the reduction potential is the one that will be getting reduced. And the one with the lower reduction potential will be oxidized. And same goes to the oxidation potential. If you're not given reduction potential, you're given oxidation potential, then the higher oxidation, the bigger oxidation potential is the one that is being oxidized, and the other will be reduced. Alright, so let's say the reduction potential is, for nickel and copper, right? And now for this one, it's 0.38, and this is 0.11. Alright, both of these are made up because I don't have the numbers next to me, but let's assume this is what you're given. When you have a reduction potential higher than the other one, that means this one is getting reduced. So Ni will be gaining electrons. Ni 2 plus 2 electrons forming Ni. And this one will now be oxidized. And how do you know what the oxidized potential is? Well, you're gonna have to turn this into a negative, add a negative sign in front of it. So if this is originally negative, now it will become positive. But since it's a positive, now it will become negative, and this will be the oxidation. And this one will be Cu making Cu2 plus 2 electrons. And I'll see a reaction in this thing. And now to calculate the overall electrical potential of the cell, it's E cell equals E reduction plus E oxidation. Now some textbooks show it the other way, but this way I think it's very easy for me to remember because it showed me the reduction over here. So this is 0.38. So E cell equals 0.38 plus E oxidation, which was the reduction was 0.11, but since I converted into oxidation, I had to add a negative sign in front, and now this is turned into negative 0.1, so it's negative. So it's minus 0.11 plus negative 0.11. Now when you add together, it's 0.27. A positive 0.27 means this is spontaneous. A positive cell means it's spontaneous, and a negative means it's not spontaneous. Alright, now let's talk about a salt bridge. So a salt bridge contains an insoluble salt in both substances. And how the salt bridge will work is the cation of the salt bridge. Salt bridge is usually stuff like NaCl. And so the cation of the salt bridge will go into the cathode, and the anion will go into the anode. And then now the salt bridge is taken care of. Let's talk about ways to find non-standard cell potential. So You know that the standard cell potential is E of reduction plus oxidation. Alright, now let's talk about non-standard cell potential. So E cell, which this needs to be noted is non-standard, is equal to E cell of standard minus RT divided by NF times Ln of Q. And this R is gas constant, which you should know is 8.31 J per mole Kelvin. And now this T is temperature in Kelvin, and this N is number of moles. No, number of moles of electrons. Number of electrons being transferred in your thing. So let's in our previous equation where we have Ni2 plus and Cu2 plus, those will be 2 electrons because we have Ni receiving 2 electrons and Cu donating 2 electrons. And make sure you balance it out before you plug the number in. So if I have 1 electron and 2 electrons, you have to multiply the first equation by 2 to get 2 electrons. So your overall will be 2 electrons. And this is the total number of electrons being transferred. And this is Faraday's constant, which is 9,650 coulombs per mole. Faraday's constant. And Q is a reaction quotient. So as Q increases at a given time, and Q is you should know is products to the most power divided by reactions to the most power, like K equilibrium, except not at the equilibrium point. At any given point is a Q. As Q increases, the E cell will decrease, and as Q decreases, E cell increases. So when Q increases, the cell will become less spontaneous, and as Q decreases, the E cell will become more spontaneous. Now let's talk about the second way. Right now this should be a fourth way to calculate delta G, and that delta G is equal to negative NF times E, and this is again the number of moles of electrons. This is Faraday's constant, which is 9,600 coulombs per mole, and this is the standard reaction potential in V. Standard reaction potential in V volts, which is also joules per C. And this delta G is Gibbs free energy, and since we're using joules over here, this will be in joules, so make sure you divide it by 1,000. And now let me draw a handy dandy chart over here for you to remember. This will be, actually, let's draw this. Alright, this is E cell over here. Here the K is the equilibrium constant, and this is going to be delta G over here. So to convert from E cell and delta G, we're going to use the formula delta G is equal to negative NFE cell. To go from E cell to K, we're going to use the formula E cell equals negative RT divided by NF times Ln K. And to go from delta G to K, we're going to be using the formula delta G is equal to negative RT Ln K. And that is how you get to how you use all three of them. How you get the result of all three of them by using each other. Alright, so now let's talk about the second type of cells, which is electrolytic cells. And these are cells that must use an electrical energy to drive the reaction, which is going to be non-spontaneous. And these are not as oftenly tested as Voltaic cells, but the concept is the same. And then we'll also be talking about Faraday's law, which is current is equal to I is equal to Q divided by T, and this Q is going to be in charge in coulombs, and this is going to be time in seconds. and this I here is a current, which is in amperes, amps, A. And a Faraday is basically a mole of electrons. And so our second formula is that Q is equal to NF. Q, which is our charge in coulombs, Q is equal to the number of moles that are being exchanged times Faraday's constant, which is 9,605 coulombs per mole. And a handy dandy way to link all of them together is, so first you have minutes divided by, it'll be a long stoichiometric equation conversion. So first you have minutes. Let's say you're given with minutes, and now you need to convert from minutes to seconds. And now to convert from seconds, you can have a placeholder over here and a number of amperes on top, amps on top. And now that I have seconds and amps, you can use 1 coulomb over 1 amps times 1 second. And the reason so I should have mentioned up here is because current is equal to amps times seconds. So now that I have 1 current up here divided by 1 current up here divided by 1 amp times 1 second, that is going to be equal to 1. And now you have amps and seconds, you can cross the seconds out and all the amps out as well, and you'll be left with coulombs. And now from coulombs, you can go with 9,605 coulombs for 1 mole of electrons. And now from 1 mole of electrons, you can go from, let's say, reaction. The previous reaction we used Ni 2 plus 2 electrons makes Ni. And in this, there are a total of 2 electrons. So let's just use this example. And for every 2 moles of electrons, you have 1 mole of Ni. And then from moles of Ni, that's how you result your answer in moles of your substance. Or if you want to go farther, you can convert from moles to grams. And that is how you get for however much minutes and however much amps that specific amount of substance gave off.